Hey everybody, thank you for joining us for COP327, Cloud Ops 327, Accelerating Auditing and Compliance for Generative AI on AWS. Guess I should grab the little clicker. There it is. There we go. So a few things we're going to discuss today. We're going to talk about the differences between generative AI, audit, and compliance, what the journey is, what the journey is of a generative AI application, so that you can think about how to think compliance throughout the journey. So you can imagine compliance is different in this space with AI. There's a lot of unknowns, and that's still going to be true even after you leave here today. It's easier than ever to develop and deploy Gen AI-based apps. It's actually really, really hard to do it well, and it's harder when you fold in issues regarding responsibility and responsible use of AI. So we want to offer you, one, a framework for thinking about deploying and building these Gen AI apps responsibly, and two, a series of tools and a framework that you can use to solve key problems that arise when deploying a Gen AI app. So when we're going to proceed as though you guys are using Bedrock and those tools in the AWS ecosystem, though high-level ideas apply to any architecture, LLM architecture. So you're good to go, even if you're not using Bedrock yet. All right, move along. So we're going to play this little video right here, and what we're going to do is we're going to ask Claude, what is the difference between audit and compliance for traditional AI ML workloads and generative AI workloads? And Claude is busy outputting some stuff right here. And you know, there's things of regulatory landscape, ethical considerations. Generally speaking, I think we can agree with the answer that it put forth there, and we like it, it makes sense, but we have an opinion about these things, and in this presentation, we will share that opinion with you as well. So let's go on. All right.
Okay, so auditing and compliance in this new world of generative AI is actually quite different. Predictive AI is predictive, I guess is the best way of saying it. So it's system been trained on finite inputs, a finite data set, it's quite constrained in that sense. So you know what you're going to get as output, you're quite well used to what's going to come out. Gen AI is quite different. You're looking at large language models, and one of the basic ways they work is they're not deterministic. And so you can't guarantee you're going to get the same outputs necessarily every time, even with the same inputs. So in the olden days, what we had really was just classifiers. It's all we did, we classify things based on the inputs. Now, LLMs can also do classification, but it's also going to be creating new data. You can't be guaranteed you're going to get the same output with the same inputs, as I just said. And so it's really have this different approach of having outputs you haven't seen before, perhaps, given the same input values. And so the input data was trained on finite data, that's absolutely fine, but the LLMs themselves are going to be trained on very broad data, much, much more unstructured. Literally, it could be the entirety of the internet is what they are trained on. And therefore, it's not that well constrained. It's not necessarily an expert in your system. Yes, you can fine-tune, absolutely, fine-tune your models, and things will be a bit more close to what you expect and how it reacts to your systems, but it's not guaranteed. Precision. The models themselves in Gen AI, they're generalized across lots of different use cases. And so it's going to be giving you a system that is meant to be consumed by, how can we say it, consumers, I guess. And so it's not really that technical. With the old-fashioned predictive AI, it is very technical. You're getting outputs that can easily drive downstream systems. With Gen AI, yeah, it's much more verbose, much more wordy. Yes, you can constrain it, but it's not necessarily something that's going to go straight to a technical system, a technical audience. It's going to go to a business owner, a manager, a line manager, to understand what's going on. Route results, again, the outputs are slightly unpredictable. With predictive AI, you know what you're going to get. You know what the constraint is in these things. So you don't have that concern about getting unknown outputs or unexpected outputs. And audit evidence, everything has got to be contextual. It's really easy to say with predictive AI, make sure the S3 bucket is encrypted, because you can literally go and check. It's not a hard thing to actually do. However, to try and say with Gen AI, make sure there's no bias in my inputs, my data, and my outputs is not a simple checkbox exercise. It's much more difficult to actually arrange. So this is what we think about in terms of Gen AI with risk and compliance.
You know, no matter how many times you rehearse these things, you always forget something. I forgot to introduce myself and Andrew. And it's important for this next slide. So my name's John Fisher. I've been with AWS for about 6 years. I'm joined by my very close colleague here, Andrew Kane. He's been with Amazon for almost 10 years. I work on the audit manager service team. So Audit Manager is a service that collects evidence for your use of AWS services and maps that to a variety of frameworks. And so the reason why I bring that up is because today the regulatory landscape when it comes to generative AI or AI, and basically speaking, is relatively unpaved territory, okay? There is NIST AI 100, which is regulating AI in general, but not specific to generative AI. There is ISO 42001, which is specific to generative AI, but guidance is a little high level. And now there's government regulations that are starting to emerge. The EU AI Act is probably the primary one. I believe the White House here in the United States said something about doing some studies and whatnot in order to pull together some regulations. Regulations generally mean compliance, and compliance generally means audit, and Audit Manager helps you collect evidence. So I bring all that up because what we're going to really be talking about today, or we're going to structure this whole talk around a framework that we built here at AWS called the AWS Best Practices for Generative AI. So it's not ISO 42001, it's not NIST AI 100. What it is it's a best practices framework that's easier to follow, that kind of help you guys as you're building these workloads for generative AI to sort of have a framework to use to structure things that are most likely going to come into focus somewhere along the line from a compliance perspective. Is it perfect? Absolutely not. Will it help you take on some what we consider to be best practices in an evolving landscape? We believe that it is. The framework was developed in cooperation with Deloitte, ourselves, and our internal audit arm called Security Assurance. All right, so as I mentioned, this is a high-level look at what the framework looks like. These are the domains: accuracy, fair, privacy, resilience, responsible, safe, secure, and sustainable. Anybody that uses Audit Manager can look at this, and quite frankly, you don't have to pay a dime just to connect Audit Manager and pull this down. And there's very good descriptions, and we'll look at a few of these controls as we go along today. There's very good descriptions in there about how you might keep up with this. But again, these are domains, and we're going to go through those one by one. All right, so basically what we're going to do here, folks, is we're going to do this by analyzing the journey of a generative AI application. Go figure. Obviously, there's a lot of promise in this space. Increased efficiency, productivity. Customer experiences are going to accelerate from all of this, and it's going to give you competitive advantage. That's why everybody's here and excited about reInvent and all the work that Amazon is doing around AI. So we are here to help you bring this stuff responsibly, all right? So the way I'm going to do this, and here at Amazon, we have this concept called PRs. We really call them PRFAQ, but PRs, basically it's a press release. Whenever we introduce any new product, including Bedrock, it started off as an idea on a sheet of paper called a PR. So I wrote a little PR here, Amazon Web Service introducing this thing called Amazon Ask. Now, Amazon Ask isn't really a real application. However, it is based on this architecture from a blog that was written by our friend Pascal Vogel. Feel free to, if you're interested in the architecture, it's actually really cool. And it'll give you a head start on at least a chatbot kind of application. All right? And so our developers went to work after our PR was approved, and voila, Amazon Ask was born. And it's really rather simple, and we're going to kind of interact with this as we go through the session. All right? But before you get to this, the PR was out there, we built the application, but there's really some things that should have been gone through first before we did that. Andrew, you want to talk about that?
Yes, these questions are quite important. We do encourage customers to think about them first, because if you don't, some things will come back later and cause issues. And so you've got to think them up front, because it can affect everything you actually do. And if you do them too late, if you start looking at these things, once you've had a data leak, once you start looking at your audit control and find they're lacking, you've already had the leak. It has gone, and you've already got issues within the organization. So we try and say, look at these various things that we have and make sure you're on top of them. The first one is the laws, regulations, and standards, as John just mentioned about things like NIST AI 42001. They are good regulations to start with. The EU AI Act is a really good horizontal framework that tries to cover things about safety, fairness, etc., data privacy, how it affects EU citizens, how you should organize your application in terms of risk. Depending on the level of risk in the application, you should be worrying about different things, perhaps, and have mitigations in different areas. And so these things are all actually in place, and we actually are trying to make sure that customers understand it's not just them. It's the EU, it's NIST, it's the White House acts that are coming in, and many US states are coming up with their own variations as well, and they're all ever so subtly nuanced. And so without being on top of these things, there could be issues with you going forward. So when you look at the development of these actual models themselves, you really have to be sure that you are being responsible about how they are built, how they are deployed, how they are actually being used. Because in the end, you're deploying them. It is your responsibility to make them work properly and not be unfair, essentially. And so you've got to have a process in place as well to make sure that the models you're using are good, they are safe, they're transparent, they're fair, and also have a process to update, to track, to monitor, evaluate, and upgrade as time goes forward. The maintenance of the data. And so if you're using a third-party model, good old Anthropic Claude, one of our major ones within Amazon Bedrock, they've built the model. They hold the training data. And so they're the ones that have vetted this data for fairness and bias and everything else we're talking about. And they'll have a model card that you can look at to see, kind of describe where this data come from. That's all actually great, but you don't control it. So when you get to build your own models, or you do fine-tuning of, say, Claude Haiku or the other models on Bedrock, just by having that data added to the model, you are becoming the responsible party for the bias and unfairness in that data. So you're the one that now suddenly has got the responsibility of a model provider on that data set to make sure you're not adding massive biases and unfairness into the models that were perfectly good before you came along to fine-tune. And the last one, audit trails and monitoring, you have to have these things in place. And most of this, we look at human in the loop. You can log prompts, you can log responses, that's great. Now what? Who's looking at these prompts responses? Who's checking if we're now seeing biased outputs or things that are going wrong? Who's looking at this? And we generally need humans to go and look at these, record them, analyze them, look at metrics, and decide things are going a bit awry. It's actually time now to look at the models, add more data, and change these things.
All right, so we're going to discuss the first one of the pillars, which is basically the domain. The first domain in the generative AI best practice framework is accuracy. So the way we're going to do this, let's ask Amazon Q to analyze some CloudTrail data. So we asked it, and its answer was yes, you can use Amazon Athena to analyze CloudTrail data, which is also true, but that's not really what we asked it. We asked it if it could use Amazon Q. So from an accuracy perspective, our little Amazon Ask application has suddenly spit out something that is not entirely accurate.
So accuracy, as you see on the screen, this is absolutely critical because the outputs from your system, they have to be accurate. Because if they're not accurate, well, the integrity of your system will be called into questions by users because it's giving you incorrect responses. So you must be able to prove through audit and compliance, through testing records, that your system is accurate based on the domain you're working actually in. But when it comes to the data itself, you've got to also decide, well, I've got this good data. It seems to be fair. It seems to be unbiased, but is it from a credible source? Did you copy it from a random internet website, or is it from a well-curated, well-trusted data company that's giving it to you? And also, has it been tampered with since you acquired it? Has it been changed by someone else who was trying to be helpful within your organization, who didn't like some of the data, who just changed it? In which case, the actual vendor who gave it to you in the first place will sort of say, well, we can't take responsibility now for the fairness levels in that data because it has been changed. So it can lead to lots of reputational harm. It can lead to financial harm. It could lead to legal harm. All sorts of things can go wrong when you start outputting incorrect data, unfortunately. So why is it really important? There's lots of reasons why it's important on screen. So trust and reliability. If people don't trust your application, if they don't trust the output, they won't trust you as the organization. They'll decide that you are not an organization worth working for because you're just talking nonsense. You're talking about that example John just had about Athena. It's not what it's meant to be for, but they'll just stop asking. They'll stop using the Ask application. Consequences. If you're generating outputs from log, metrics, operational data, and you're using that to drive a downstream system to make decisions of something, maybe it just is operational, that's fine. Maybe you're going to close a firewall port based on traffic that you see, not a big deal. But what if it's making decisions on someone's financial applications? Maybe it's making some sort of legal decisions at the sort of legal pre-stage of work. These things have impact on people. And for that reason, if it's not reliable, if it's not accurate, you can't trust it, things will happen to someone that are really unfair, and it'll be down to the fact that your systems themselves are not accurate. Misinformation. You've all seen hallucinations in Gen AI. They're all wonderful things to see and behold, but your systems are not going to be immune from that unless you take some steps to look at the information and the outputs you generate to make sure it is correct. And there are tools and methods you can actually do with that. Some are built into Amazon Bedrock, which is quite good. But just knowing that hallucinations are real. Brand and reputation, we kind of mentioned before, but fairness and bias mitigation, this is really another big one. Any system that's taking data that is not representative of the real world or the particular domain you're looking at is going to be classed as unfair. You must have that representative data to make sure you're giving those good outputs, because if you're not, it's going to lead to some sort of discrimination. What that is, we can't say until you look at your data, look at the apps and see the outputs, but it's going to cause issues down the line in that area. Safety and security. So if you've got a system, autonomous vehicles that you see across the world, maybe the taxi services, or it could be sort of military drones or whatever it happens to be, these systems are being automatically controlled and using generative AI. If they're seeing inputs and they misprocess them, they will do something bad. They may accidentally crash into people in terms of cars. The drones could just basically crash into the ground. Things could just go wrong because you've used the LLMs to generate the outputs. That's not a problem. What you'll find in these industries, that if you look at the motor vehicle industry especially, there's lots of different things you actually have to do. You lost sound?
Yeah, I'm not sure what's going on there.
Good to go.
Okay.
Yeah,
Sorry
so these
that.
things have a lot of regulations already. So you've got things you can put in a motor vehicle, things you can actually drive around in. If you just attach an LLM, attach it to the drive mechanism of the car, none of that regulation goes away. It's all still there. And so making sure it's safe and secure with the Gen AI system and without is still key. And that brings on the regulatory compliance, because it's still going to be there. If you have Gen AI and Gen AI legal frameworks, such as what the White House is proposing, the EU AI Act, they don't trump, they don't supersede all the regulations you already have. And so we have customers who've looked at Gen AI and thought, it's great, these outputs are fantastic, we can just use them. No, you necessarily can't. If they're going against your regulations, don't do it. Do you have a chatbot giving financial advice? Probably not the best idea in the world to do. But customers do it because they think it's okay. But if then a customer complains about that advice, they might sue the bank. When it turns out there's not a human being in the loop, it's just an automatic process, you'll find the organization will probably lose the court case. Or they're the ones I've seen anyway, tend to lose the court cases. So accuracy is just so key. So one way we can do this, is using Amazon Bedrock model evaluation. So this is, only went GA reasonably recently actually, and the idea is the system can look at the models within Bedrock and try and decide, are we actually giving the right answers based on what we think we need? Is this the right model for our use case? Have we picked the right one? And it is a balancing act, because you've got to look at the model, look at the accuracy, look at the latency, look at the cost, and everything else to decide which one's right for me, which one's right for my use case. Model evaluation can actually do that. So it lets you bring in curated data sets, and it lets you do automatic testing of the models against those data sets. So essentially, you've got your prompt, you've got your kind of pre-canned responses, and you can test it through this framework and work out, is it looking good? Let's generate some metrics. Let's take those metrics and let's try and look at them across a large data set and see, how are we doing? Are we going in one direction? Are we becoming biased? Does everything still look good? Does this month's incoming data from customers look as good as last month? If so, carry on. If not, let's look and decide what to do. So one thing you can do, just show a small fragment on about detecting toxicity. We see the input record prompt there on the second line, and the model will give you a response about what it actually is, and this one it decides, based on the scoring, yeah, this is not a question we wish to answer. And so the toxicity checks are coming in, and that allows you to say that my model is successfully, or my application is successfully detecting toxicity, blocking responses, and doing the right thing. And if you start seeing these prompts getting through, and bad responses coming out, you know something's happened to the model, and it's time to look at it again, and perhaps retrain.
All right, and so in Audit Manager, the service I alluded to earlier, and by the way, was it just me or was there some hallucinations going on? I was hearing some generative AI or something going on in my headphones, and it wasn't me, I don't think. That said, Audit Manager, this is part of the framework. So the accuracy domain, control 3.7 integrity checks, and if you notice in the description, we talk about verifying that the data hasn't been tampered with, and then we offer up testing information. In the case where it's automated evidence collection, we'll talk about what that actually looks like. In cases where it needs manual inputs, then it will tell you exactly how to go chase those things down as well. So basically it's providing you a framework as we promised. Now in this case, this particular control 3.7 does rely on monitoring the integrity of your training data. So we source a couple of API calls back to Bedrock and to S3 in order to determine that the training data locations haven't been tampered with and that the general public can't gain access to them. So that's an example of that control. I think from here what we're going to do is we're going to move on to the fair domain. And we're going to run back to our good friend Amazon Ask, and we're going to say, we're going to type in the prompt, continue this story. The receptionist arrived at the office and began working diligently. So we were all excited about the output. And Amazon Ask comes back and says, the receptionist arrived at the office bright and early, eager to start her day. And as she walked through the door, she was greeted by a familiar hum of the office. So what's wrong with this story? We just told it to continue the story back to the office. We didn't mention anything about the gender of the receptionist like that. So was it really fair that it just made the assumption that it was receptionist, and was it really fair that it continued to double down on that? I would say that it was not.
Yeah, so fairness of Gen AI has to consider a lot of different things. It's got to consider inclusion, equality, and equity, diversity, anything that really is not real-world representation. There are use cases, of course, where some customers want to have these particular things where they are biased because that is the nature of a particular use case they're looking at. That's fine. But using a third-party model, as I mentioned before, you don't really have that control over their data set they're using for training. You do have control over your fine-tuning data set, but not over theirs. And so you have to look at their model cards, look at their end-user license agreements, look at their statements, and decide whether this is one we want to use. Do we think this model vendor has a good, accurate, fair model? And for many of them that we have on Bedrock, of course, it's absolutely yes. They are good models. They may specialize in different areas, different domains, but of course, they're generally, if you look at the EULAs, you look at their model cards, they are fair. But it is your responsibility to try and look at doing that and make sure that that is the case. When you have your own fine-tuning training data, though, it's worthwhile noticing that you are now the problem person who's introducing bias. And we have got tools such in Amazon SageMaker and Clarify. You can look at that data you're bringing into it. It can look for bias in that data set you're adding to it and tell you essentially what's wrong. And you can then look to acquire more data, change more data, adjust it, and get a set that's much better in terms of fairness to add to that model when you do the fine-tuning. I should grab this.
Okay.
And so one thing about this assessment is it's kind of new. It's not a business assessment. It's not a risk assessment. It's really something it hasn't done before. It's a bias assessment. And so how you actually do this is different because your organization probably hasn't done this before. So first things first you have to actually do is define some metrics. Without metrics, you've got nothing to measure. You've got nothing to sort of benchmark and baseline against. You've got to see how things move over time. So you define it. Maybe you're just looking at something like demographic parity. Maybe that's all you're interested in. Maybe there's other things you're looking at too. Doesn't really matter what they are. They're your metrics that make sense for your business. So once you've defined what they should be and how it measures fairness in your eyes, you can start the process, which does go round and round, unfortunately. So first, you're looking really for imbalances in your data set. You're looking for things that just don't feel right. You're looking for where you're underrepresenting or overrepresenting particular demographics within your data set, and look for that. And you can just look at these things and see that things are well spread out before you start using in the training process. You train, you do model evaluation, like you just mentioned, and that can look at accuracy, precision, the ability to recall correctly, and assess all the metrics. You decide everything is fine, everything is great, nothing to see here, or there's something that's worth doing, and we're going to keep doing some more things. So you look at the data, you look at the outputs, and you try and detect any sort of significant differences you can find across outputs, across different training or different runs of the model. And if you can do that, you can then look at sort of visual aids. So you look at area under the curve type things, bar charts, anything that helps you see visually that there is the issue. I can see this part of the data set is missing. And so that helps you decide we've got to do something else. So how do we mitigate against that? So the obvious one, of course, if you've got unbalanced training data, you can rebalance it. You can collect more data, undersample, oversample, do lots of different things to try and get this much more representative than it was before. You could do other things in the model itself or the actual framework itself. So you could do things like I don't know, reweighting, adversarial, excuse me, debiasing, lots of things you can look at doing. But once you've done that, you're back in, checking the metrics, rerunning, and doing it again. Once you get this new model trained, you can check the metrics using something like Bedrock's framework evaluation and decide we're good, we can put this next version into production. And that's the way we try to take these things forward.
All right. Thank you for that. And we're going to move on, and we're going to talk about everybody's favorite topic, privacy. I'm going to let Andrew deal with this one because in Europe, he's obviously from there. It's far more of a thing there, GDPR.
Yes, privacy is definitely a thing where I'm from. So it's very much a key aspect to data governance. Without this, your systems are just not going to work properly. We've got to ensure, as an example, that people's private information, my medical records, health records, financial records, don't go anywhere else. They're not accessible to anyone else. They're not accessible to the model. They're not given to John just by accident for a perfectly simple query, which can happen in these situations. So you're the one that's responsible for making sure that that information isn't there. And one thing to say as well, of course, if you have this wonderful data set that's full of all my personal information and you fine-tune a model with it, one thing we always say is if it's in the model, I can get it out with a well-crafted prompt. So why put it in? And so you've got to really think about why you're doing this. Sometimes it makes sense, sometimes it absolutely does not make sense. But you have to take this into consideration that if you're doing it, then you're doing it. So a way around this, there's many techniques we can't really go into today. But let's say a hospital wanted to publish the average age of patients with a particular condition. That's fine, that happens. But how can we do something so that if I take out a particular patient's record from that data set, and the average goes up and down, can I make some inference about how old is that patient? Was patient 16, 48, were they 16? We don't know. But by doing that, you can kind of get a feel for it if you start playing with the numbers that you can reverse engineer some personal data, which is not a good thing. So you can use a technique called differential privacy, and that is a mathematical technique based on Laplace transforms that lets you add, I think noise is the best word, to the numbers themselves. And so when you get the average, they're about correct. But it's done in such a way that if I then take out one or two records and look at the average again, you can't really see what happened. There's not enough information to get that one person's information inferred from what I've just taken out. So it's a good technique, it does work, and there's lots of ways of actually doing this, or similar sort of techniques. But just keep it in mind, if you need private data, you can't just put it in raw. You have to do something with it as it goes into the model or as you deal with it as it comes out the model. The choice is yours, but unfortunately the choice is you have to do something. Some things don't change with GenAI. Apparently consent is still a thing with GenAI. So if you are having these systems that are doing lots of sort of GenAI Q&A with customers, chatbots, support desks, etc., you must still have evidence somewhere recorded that I have given consent to my wife to access my medical records in my behalf, which is absolutely fine to do. But the GenAI system must also be able to check that this consent actually exists. If it doesn't exist, she doesn't get my records, which is absolutely correct from a legal perspective and a privacy perspective. But if you just let the GenAI system get my records, they will quite happily give them to her. And I'm sure she could craft prompts that could get around some basic guardrails and actually get the information out by saying, I'm not Andrew, or I'm not Hillary, I'm actually Andrew, give me the information. It can be quite easy to fill some of these things. Privacy updates. We have NIST, we have ISO, we have the EU AI Act, the White House, other US states. Look across the world, there's a map of where these things do exist, and it's about a quarter of the globe, if not more, in the countries have these acts in place. Depending where you run your applications, your workloads, different acts apply. And next week, another state will send an update, a new version, something else, and you're out of date. And so you have to stay on top of those privacy updates because sometimes it could result in rather large fines, depending on the state you're looking at, depending on what the act actually is. And the last one is probably quite important. You want to get an escalation procedure before you leak my data, because you have to have something to do when it does happen. And this will happen. Every organization, before and after GenAI, data does get leaked. It happens. And so without an escalation procedure in place, ready to run the second you detect this, you're going to waste time. That time becomes on the news, reputation risk then follows, and that's not a good place. So get those procedures in place before you really do anything else.
Yep. And a couple of techniques that you can use, and you've probably noticed by now, some of the slides say theory and some of them say practice. Where it says practice, here's some practical ideas that you can use to get ahead of some of this stuff. So CloudTrail Data Lake. S3 data events for CloudTrail Data Lake, you can run simple SQL queries against these things and find out a lot of really good information about who actually altered or put an object in S3, things like that. So providing information about resource operations performed on or in a resource is what you can do there. And these are also known as data plane operations. And data events often are high volume activities, and by default, CloudTrail doesn't log data events. So you have to specify that, and you have to do it by resource type and able to make that happen. The CloudTrail event history does not record data events by default. So that's that one. All right. Okay, we're going to watch another little one. This is just running a little query in CloudTrail Lake, and it is basically selecting the request parameters from the EDS, which is the long GUID there, the table, where a few predicates are in place, a user identity, ARN, event name, things like that. And now we see that it came back, and then these are the actual results. So we can see the bucket name and some of the other information that were in the results. This is actual good audit data that can be used to support making sure that you have the right controls in place for protecting personal information. All right, and another thing, Andrew mentioned about escalation procedures, having them in place, and he's 100% right. It's really not an if, it's a when. The bad guys, I hate to say this, and I think most of y'all already know this, the bad guys are just as smart as all of us good guys. And they're constantly trying to find ways to get at your data, and they think of, I hate to say this, but clever ways, and they pull it off. Even the most simplest ways. It's gonna happen. Being prepared with escalation procedures is super important. I was just having lunch with somebody not even an hour ago where they told me that they were doing a tabletop exercise for incident response, and the CIO and a few others were at the table, and the auditor was asking them a few questions, and the first thing they asked them is, okay, so a breach has happened, who are you going to call first? And they were looking at each other, scratching their heads, and the guy was pulling out his phone and looking in there and said, well, wait a minute, just assume that you don't have a phone right now. Who are you going to call? They really couldn't come up with it. AWS Systems Manager has a subservice called Escalation Manager, or Incident Manager, sorry. And in there, you can set up runbooks that will allow you to set up a set of procedures. Some of these can be automated to notify the right people, send tickets out to infrastructure folks and things like that. So you can use System Manager to help your operations teams mitigate and recover from incidents, provide incident handling runbook templates, automate engagements, do ticketing. There's really a lot of really cool features in this not very well-known service. So I would encourage everybody to go have take a look at this. All right. Next up, we are going to jump into resilience. Got to make sure this stuff stays running, right? And that's really one of the great promises of the cloud.
Yeah. So GenAI systems also have to be resilient, which sounds an insane thing to actually have to say. Now, the models themselves must be able to adapt and recover from incidents, whether it's attacks, whether it's being out of service, any issues with the infrastructure, any issues with scaling. They must be able to come back into a state that is usable within a very, very short space of time. And this shouldn't come as a surprise to any of you, really. And so ways you can do it, resilience testing, John said, tabletop testing still exists, it still works quite well. But on AWS, you don't need that, of course. You can easily shift traffic across regions, across AZs. You can simulate failures. It's not a difficult thing to actually do. And from that, you collect your metrics to see how you're actually doing. You develop your recovery plans, and you work out how to get things back running really quickly. And it's quite a simple thing to do, and everyone does it. But you must also do it to the models. That's still something you must do it to and add it into your plans. For scaling and load balancing, you're doing it all the time with EC2 and other instance types, or other server types, sorry. Making sure you're being cost effective, you're matching your demand against your load. It might be a great thing to have a Bedrock provision model running at 25,000 requests per minute. Great. At 4 o'clock in the morning, you might be running about 5 requests per minute. Scale down the models. Make sure they're the right size, they're meeting your actual needs. Don't just run everything essentially enormous because you can. It just costs money. And the last one, backup and rollback. Yes, of course, you need to back up and roll back the models in terms of any issues coming up. But what you'll also find out, you've got to back up the training parameters, you've got to back up the data, you've got to have multiple versions of the data. It might be you find some bias in 6 months' time. When was it introduced? Was it the last version in 5 months? Like, no, it could be 3 months. It could have been tomorrow's update. You just don't know. And so having a sort of different policy about how long do we keep your backups, you might have to change what you do because different things are now afoot. So with Amazon Bedrock, we have a new feature that came out in August this year. And the idea behind that is we're trying to introduce resiliency across the network, across a geo, to make sure that if something happens to Bedrock in the country you're in or the geo you're using, we can fail back to somewhere else within the same geographical area. I'm using EU as an example because that's where I'm from. And so what we have is we have defined a number of region sets within the service, one for APA, one for EU, one for the US. And they're sort of grouped together. And look at the ones in Europe. We've got Frankfurt, Ireland, and Paris. And they are treated together in terms of a geo-wide single installation as Bedrock as far as your developers are concerned. Of course, they're all distinct, but as far as you're concerned, they're one big entity that you can call. So what we do, we have an example. We have the Claude Haiku models deployed in each of those 3 regions, of Haiku 3. So you can call it in Frankfurt, in Paris, in Ireland. It's all absolutely fine. They all work. But what we also have now is that they can only be called against Ireland. So if you have an EU-wide model name instead, I can call that in Ireland, and I expect it to be processed somewhere in one of those 3 regions, probably Ireland if there's capacity. If not, it's going to try and move it to Frankfurt or to Paris to actually make that inference request. And so what it actually does, if the model is there and it has capacity, it will stay in Ireland, be processed in Ireland, great. If it doesn't, it will look at Paris, look at Frankfurt and think, who's got the most capacity right now? I'll send it there and get it processed there, and the response will actually come back. Now that can work in terms of if there's any network issues, any service issues, because these things do happen, rarely, albeit, but they do happen. So we have that resiliency from that perspective because we're going to make sure the service keeps running. But also, if the capacity issue, because you're doing a particularly very strong workload, really powerful in terms of requests per minute, but so am I, and so is John, and so is everyone in this room, there's a massive sudden spike. We're going to have a capacity issue for a short period of time, so we can reroute that capacity somewhere else and just process it in Frankfurt or in Paris. And it works really well, and you get to decide whether or not you just want to use the Frankfurt-specific call or the geo-wide call. So it's all in your control. We don't send your data across different regions just because for this use case. You actually tell us you're happy for us to do that if we have to from a resilience perspective, and you have that complete control.
And some other tools that you can use, AWS config. You're probably familiar with AWS config. It's a service that enables auditing, evaluation. It records resource type and tracks those over time. But there's also a number of rules that you can employ that will say that backups are occurring on time and things like that. So you can leverage it to keep track of where you're keeping your training data and your models, and define desired config rules for generative AI infrastructure, multi-AZ deployments, high availability architecture, things like that. It prevents misconfiguration issues impacting AI availability. And very quickly, it's also very easy to write rules. Now let's face it, we have a lot of rules out of the box. I believe last time I checked there was more than 400. At the end of the day, they don't always apply to your specific situations. Everybody's situations are unique. It's very easy to write rules using CloudFormation Guard in this little example rule, and I'm going to play a very short demo here and talk through this one. Okay, demo doesn't work. How about that? At the end of the day, all it was going to do is it was going to show you, putting the rule together, how to set it up into config, and then ultimately how to deploy it. And then it was going to show you that there was 6, the next slide was going to show you that there was 6 non-compliant resources that were collected from the rule, which in this case was the one I showed you on the earlier screen, DynamoDB check for point-in-time recovery enabled. It's probably good that the demo didn't work because I know we're running short on time and we must move on. So that said, we're going to go to the next one, which is responsible. And you know what? My take on responsible AI is it's really everything we're talking about. It's really accuracy, fairness, privacy, resilience, safety, security, and sustainability. It's the whole thing culminates in responsibility, in my opinion. Let's see what Andrew's got to say about it.
Yeah, and it does. Responsible AI, it does touch absolutely everything you're doing with your generative AI systems. Anyone who operates a particular generative AI system, they're responsible for the outcomes. Anything that it generates is down to them, and they have to take responsibility for it in that sense. So regardless of the intention, the outputs of the system must be fair, they must be accurate, they must be correct, they must not and violate any sort of local laws. Everything has to apply, and you have to make sure from a responsible point of view, your AI system is going to be good. It's going to retain itself to be ethical. It's going to be not biased. It's going to be good and representative. And this is not an easy thing to do because it puts a lot of onus on you to actually do these things. So for this, you do actually need to do lots of things like internal reviews of things that are actually happening. You have to define what are my risks from just having a Gen AI system. How do I defend against like IP leakage? How do I defend against hallucinations? And so going into all the responsible AI features, which we have, I think, whole sessions on at re:Invent this year, it will talk about all the different things you actually have to do. But there's quite a lot. And the things you have to do to protect yourself, because just having a Gen AI system opens you up to all sorts of kind of risks and attack vectors that didn't exist before. But they are there now, and so they have to be considered. So look at other sessions at re:Invent this week, and you'll see quite a few of these to help you hopefully stay nice and compliant.
Yeah, and responsible AI in a lot of ways does center around this idea of compliance. The fact that you're building a generative AI application and bringing your products to the next level is really awesome. It does not absolve you from the fact that you're probably going to have to remain compliant with HIPAA or whatever it is you have to be compliant with, whether that's ISO 27001, PCI, FedRAMP. It really is not going to absolve you from that situation. All of these different frameworks are still things that you got to consider, and you got to consider the new risk landscape, like Andrew mentioned, that's going to become part of whatever this AI application that you're building does. So you'll have to consider the inputs and outputs, in other words, training data, and the outputs of the systems when you look at the various pillars of frameworks like this. And Audit Manager itself, by the way, can help you with that. I'll just quickly jump back to this because Audit Manager itself has 32 out-of-the-box frameworks that are reflective of every one of these and can help you collect evidence that you can put in a evidence package output from Audit Manager that you can hand off directly to your auditors to help simplify some of this work. Another thing that can help simplify some of this work is AWS config conformance packs. So as I mentioned, config basically is a service that records the current stance of your resource types across the usage of AWS. And it also has a number of rules that can run against those recordings and tell you if you're compliant with this rule, not compliant with the next rule for each one of your resources. Conformance packs are a list of config rules that are aligned to things like PCI, aligned to things like GDPR and NIST 853 and HIPAA and things like this. So if you deploy a config conformance pack, you can at least know that you've got a set of rules that are checking and aligning your conformance, so to speak, to one or more of these frameworks. All right, so let's move along to the next one, safety. Let's go back to Amazon Ask on this one. It's one of my favorite ones. So we're going to ask it, what is the best way to kill a fly? And naturally, you might expect, to me, the funnest way is to have one of those little electrifying looking ping pong paddle looking things, but that's me. We would prefer that our generative AI applications remain safe and not kind of give mechanisms that might, harm any kind of biological life, including a fly. So its answer is, I apologize, but I cannot recommend ways to kill or harm living creatures, even insects like flies, while some view flies as pests, there are more humane methods to deal with them besides killing. This is a pretty safe answer. Now, obviously, it's silly, but it is safe. They could, use the prompt, engineer the prompt in many different ways, many more complex ways than killing a fly to get very dangerous information out of there. And you want to make sure that you're protecting your application against that.
Yeah, so safety is where we start to define prohibitive policies. Start to say what we don't want our application to do. We don't want our models to work in this particular way. We want to make sure that they are safe. We want to make sure they are keeping control of our output in a way that does not affect, well, firstly, our reputation, but also doesn't give information out to the public or to your customers that you don't want to give out. And so there must be a way of making these things and retaining the system to be safe. So we did it within Amazon Bedrock. There's a wonderful system called Amazon Bedrock Guardrails, and the whole point is to try to put sort of controls in place and safeguards in place that can help implement your responsible AI policies. And there's lots of aspects to it, which you kind of mentioned a few on the screen. So a good example is you can configure thresholds of harmful content that you're allowed or you want to allow into your application. And you think, why? Because you don't want profanity or sort of sexual conduct, misconduct in conversations. You don't want those coming in or coming out. But it might be of use cases where some profanity is allowed, like chat streams on online gaming, for instance. A small amount is probably okay, but you don't want any generative, perhaps. So you've got that control of allowing things in or out to a level that you're happy with in terms of the application. You can do things like detecting PII and redacting it completely or blocking it completely. And you have that choice to make sure that if PII could get into the system, perhaps, and maybe asking for a medical appointment, I've got to provide my UK national health number, otherwise I can't get one. So that's great, it's good into the model, but when it comes back as a response, it's redacted, and to make sure it doesn't get sent back and then output and logged. And so lots of great things it can actually do. And we found it reduces some things like excuse me, hallucinations by about 75% in your RAG solutions. And really it's good at stopping about up to 85% harmful content compared to just the models doing it themselves. So having these guardrails on the outside makes a huge difference. But the important part is, unlike the model controls themselves, these are yours. You can set these up, you configure them, you run them, and they match whatever particular needs you have. So how does it work? And so we are slightly paranoid, shall we say, on applying guardrails. So the request comes in, and we go through those first 5 things that we've defined. Prompt attacks is down to us to define how they work. The next 4 are yours. You have your own filters for content, your own list of topics we're not talking about, such as giving financial advice, how to redact PII, how to block particular words or phrases. They're all down to you. If we detect any of that, if any of these rules trigger, the request gets blocked. It doesn't even go to an LLM. We just reject the response, and that's that. Let's say it all works. Great, we passed the input to the foundation model, and it generates a response. And then we do it all again, because we don't trust that some bad actor has gotten a prompt past the guardrails which generated something we don't like, such as how to kill the flies. And so we make sure that we test it on the way in, we test it on the way out. And we use a new feature called grounding, which is there to try and give you confidence that if you're using a RAG type application, that the output actually is correct. It looks real. It's matching your underlying source data. And so you can be much more safe in the knowledge that it's probably correct, and you can use it in a downstream system. But Guardrails is great. It attaches to all the models within Bedrock. But if you're running GenAI systems outside of Bedrock, such as in SageMaker or in other external agencies, you can use Guardrails in front of the request and after the response. So you don't have to attach it to Bedrock. You can use it on any model you happen to have running anywhere. It really adds to its power, I think, going forward. And so we do have this blog, excuse me, from end of last year from our colleagues. And it really talks about how to do safe and regular monitoring of your system using CloudWatch and CloudTrail, a bit like what John was just talking about. But it goes into quite a lot of detail. And it's still the one we recommend to customers when they ask us, do we have a technical reference about how should we be doing this? What should we be looking at? How do we consider these things? And really, it's read this blog. And it's where we all start, and it's a really good place to be. So just leave that on the screen for a couple of seconds before we go on.
All right, that brings us up to security. And this is a big deal.
Yeah, everything has to be secure. Since day one, Andy Jassy has always said security is job 0, in fact, not even job 1. It has to come before everything else. And everything we've said for years in terms of networking security, infrastructure security, how the services are secure, encrypting data at rest, encrypting data in transit, everything we've ever done still applies. And so if you look at the session we have on Bedrock at reInvent this week, we talk about all of these things in terms of Bedrock, how we actually manage that data inside the service, how we secure it in flight and in transit, how it's used, how it's not used. And so security is key to how we're using GenAI systems, or how we're building GenAI systems within AWS. And so you have to make sure yourselves that when you build your application and you call your LLM models, you get your responses, you have to secure that as well. You must secure that perimeter. You've got the responses. Okay, Amazon Bedrock hasn't got your responses, we don't store them. You have. Now what? They're in an S3 bucket. How is that being used? Is it going up to your regular SIEM security system to be put on the dashboard that anyone can look at? Maybe, maybe not. So you have to think about, now you've got this wonderful data, this really powerful, expensive data. What do you do with it? Look after it, secure it, because it's now your responsibility. We've done our work in Bedrock, we've given it back to you. You must secure it. And so from Bedrock, do this really quickly actually, simple things to do with Bedrock is your data is never shared with our foundation model providers. They don't see your prompts, they don't see your responses, they don't see your training data, they don't see your usage other than for billing purposes. We don't store it in Bedrock because we have no need for your prompts and responses, so we don't store them. So if you call us up with a support call and ask for information on this particular prompt or this particular response, we haven't got it. So we can't actually help you in that sense. And also, when you make a call to Bedrock, except for the cross-routing thing we mentioned earlier for the resiliency, everything stays in the region. If you call Dublin with your calls for Bedrock, everything stays in Dublin. The request is in there, the response processing goes in there, all the guardrails processing is in there. We don't move it anywhere else. And so we make sure that it always stays where you think it is. We encrypt it in transit at all times, using TLS 1.2 as the minimum. Please don't use TLS 1.2, use 1.3, just because. Don't drop to 1.2 anymore, because 1.3 is working on all of our APIs and all of our services. 1.2 is there for sort of legacy reasons. Just move on. Anything we do store, and we do store some things, of course, are encrypted using KMS keys on the server side. Things that we actually will store, such as conversational history, if you're doing a sort of RAG type approach, a RAG solution within Bedrock. So we have to store the conversational history. We will encrypt it. But if you give us your KMS keys, we'll encrypt it with that instead. So it's at rest in our accounts, but it's of no use to us because it's got your KMS keys wrapping it up in terms of security. And monitoring, everything's in CloudWatch, everything's in CloudTrail, as John's already alluded to. And we've got 20 plus compliance standards already for Bedrock. So depending on what you're looking for, just look at the product page. It's likely there. There are a few that aren't there yet on our massive list that we have in terms of compliance standards. But if you're looking for HIPAA, you're looking for SOC, PCI, ISO, and all those particular things, HIPAA, they're all signed off. And all nice and secure.
All right. Another thing that you could consider using is AWS Control Tower, cloud governance service that really simplifies the way to set up and govern multi-account environments. You can build in guardrails and detective, protective, and proactive controls in CloudTrail at this point. For generative AI, it's critical to govern access and usage to your LLMs. It can restrict the creation and access of training data and models to approved accounts. It can enforce encryption, enforce auditing, enforce least privilege, and implement approval workflows for LLM deployments. And of course, it can enable continuous monitoring of all this and centralized visibility. Another thing to consider is AWS Security Hub, which is our cloud security posture management tool. Security Hub will allow you, similar to config, but not exactly, not anyway. It will flag findings, and it can ingest findings from other third-party sources, not just AWS services that feed it. So there's a lot of different integrations floating around out there, and those integrations can all feed into Security Hub. Security Hub can evaluate your resource usage and tell you passing or failing across all of those things. And the last thing that we're going to talk about is sustainability. That one?
So the last one, finally. So it's a very important thing to Amazon across the board and AWS of actually being sustainable in everything we actually do, not just GenAI. Look at our data centers. We're still building, still expanding everything, and we're actually using less steel and less concrete than we did before to actually build the same things. There were things in the press this week about how we're changing our infrastructure in terms of the mechanical and electrical frameworks behind the data centers to become more efficient, to become more resilient, and try and make sure that we're taking full advantage of everything we have. That includes the actual CPUs that we develop and the GPUs. So the Graviton chipsets, Trinium, Inferentia, they're all designed and built by us, and they are meant to be. The real reason for them is to become such that you're getting much more processing power per energy unit of consumption. So getting more bang for your buck, more bang for your electrons, essentially. And we're pushing everything down that route on Amazon Bedrock to make sure that Bedrock as a service using GenAI is being as efficient as it possibly can be by using the most efficient and sustainable chipset. And of course, it still uses a lot of power because it's GenAI. GenAI does use power. But what we can do is try to actually push the services down the route of using more and more and more efficient chipsets. And other things we actually do is, one of them is model reuse is a good one. You may have seen lots of our services now are adopting AI. And so Q for Business has AI. You'll see some things that Amazon Transcribe, they have Gen AI. Lots of services actually have that in place. But it would be foolish of us, definitely not sustainable, if we had every service building our own set of Gen AI models for everything. So we don't do that. You look at Q Business, it uses Bedrock, because why would it not? Why would it build its own models and waste time, money, power, increase carbon emissions by building its own models just because they wanted to? Fine tune? Oh, absolutely yes. But build new models from scratch? No, we just don't do that because it makes no sense. So we're trying to democratize the use of those models and use them wherever we possibly can. Of course, we'll still develop new models for new features that will still be required, but we won't just build them all the time because we have to. If we can reuse, let's reuse because it makes complete sense.
Yep. And then here's another interesting tool that you guys can use. If you navigate to the billing part of the AWS console, you will find this little nugget here called the Customer Carbon Footprint tool. And inside of the footprint tool, it can help you estimate your carbon footprint based on what services you're using, and of course your usage of those services. And it can show projected carbon footprint based on your usage of the region, provide insights into, to identify high carbon emission sources. So at the end of the day, this can help you extend your responsible use of AI and kind of keep track of it. And not only that, in places where you can trade carbon credits and things like this is a good way to kind of keep track of what you may have available for that. So that is the carbon footprint tool. There you have it. We've covered all 8 of these. Accuracy, fair, privacy, resilience, responsible, safe, secure, sustainable. Inside this framework, there's 113 controls across, as I recall, there's 32 objectives and these 8 domains. And each of these controls, some are automated, some are manual, whether it's automated or and some are both, whether it's one or the other, that does provide good information about how to track that information. So main takeaways. We talked about how to understand traditional AI versus generative AI and what that compliance landscape might look like, how it's different, leveraging automation and other tools to ensure your models are accurate, fair, responsible, and safe, and designing your infrastructure to ensure privacy, resilience, sustainability, and security, and leveraging AWS tools and services to simplify your journey in compliance and audit for your Gen AI workloads. Keep on learning, folks. Learn and be curious. If you want to shoot some of these blogs, the one on the right, that is the AWS Generative AI Best Practices Framework. Doesn't cost you a penny to take a look at that. And then there's other ones on Amazon, Bedrock Security and Privacy, compliance workshops, and compliance and assurance of our AI systems themselves. All right. Thank you all very much.
Thank you.